Hello students, how are you? Hope you are doing well. Now the question is binding energy per nucleon versus mass number curve for nuclei is shown in this figure. W, X, Y and Z are four nuclei indicated on the curve. Identify which of the following nuclei is most likely to undergo part 1 nuclear fission and part 2 nuclear fusion. So the problem is based on the topic nuclei, and in particular the analysis of this particular curve to say that which of the particle is stable. This is the curve between the binding energy per nucleon versus the mass number versus the mass number. So we know that the higher the binding energy per nucleon for a particular mass number, the more stable the nuclei is. So we have to achieve this particular range. The higher range of BEN shows the stable nuclei. Now, the first part is which one is most likely to undergo nuclear fission. Fission means the breakage of the particle. So, if there is a heavier particle, it tries to break into smaller particles, smaller nuclei, so that it becomes stable and the binding energy per nucleon goes up. So, we can clearly see that W is the nuclei having a large value of the mass number. It means that it is a heavier nuclei. So it tries to break up into smaller nuclei so that its binding energy per nucleon goes in this particular upper range. So the answer of the first part is W. Nuclear fission undergone by W. The reason is it is a heavier particle and try to achieve the binding energy per nucleon in a large quantity. Binding energy per nucleon should be large. So when it breaks into smaller particle, the binding energy per nucleon goes large. So that's the answer of the first part. For the second part, nuclear fusion undergone by the lighter particle. The lighter particle here is Z. So Z is having a binding energy of per nucleon of 5 megaelectron volt and the mass number is 30. So it tried to fuse and achieve the status of a moderate mass number particle so that it achieves the binding energy per nucleon in the upper range. So we can say that W undergoes the nuclear fusion. The reason is it is a lighter particle. This is the lighter particles, that's why it tried to achieve the BEN of a larger value, and W is a heavier particle. It tries to undergo the nuclear fission, that is breakage into smaller nuclei, so that its binding energy per nucleon goes in the upper range so that it becomes more stable. So this is the answer of this particular problem. So hope you understand the solution.